Welcome to the e-learning module, Airline Equipment Part 3. In this module, we will explore the function, construction, working principles and product line of air dryers, as well as dehumidification capacity and dew point. Here are the contents of Part 3. The function of air dryers, construction and working principles, SMC's product line of air dryers, dehumidification capacity and dew point. First, we will examine the function of air dryers. After solid foreign matter, water droplets and oil have been removed using an air preparation filter. As explained in Part 2, the air is dehumidified using an air dryer. Compressed air contains water in gaseous form, or water vapor, which cannot be removed by an air preparation filter. If this water vapor condenses due to a drop in temperature, it could cause failure of air equipment. This is why the air must be dried by the dehumidification function of the air dryer. Next, we will examine the construction and working principles of air dryers. There are several types of air dryers that use different dehumidification methods. First, we will explain the dehumidification working principle of a refrigerated air dryer. The lower the temperature, the less water vapor the air can contain. A refrigerated air dryer utilizes this property to dehumidify compressed air by cooling it, turning water vapor into water droplets. To remove water vapor, the compressed air is cooled in stages as follows. The aftercooler, installed after the compressor, cools the compressed air to around 40 degrees Celsius. Thereafter, the refrigerated air dryer, installed after the air tank and main line filter, cools the compressed air at normal temperature to around 10 degrees Celsius. This is the basic construction of a refrigerated air dryer. Compressed air enters through the air dryer inlet and exchanges heat with dehumidified, cold compressed air to pre-cool it. It then exchanges heat with the refrigerant in the cooler section, cooling it to around 10 degrees Celsius or less. The condensed water is separated and discharged by the drain separator. In the reheater section, the cooled and dehumidified compressed air exchanges heat with the warm compressed air entering from the inlet. It is then discharged from the outlet. The cooler section is cooled by a refrigeration circuit. Refrigerant gas, which acts as a heat medium, is sealed inside the refrigeration circuit and circulated by the compressor. This refrigerant changes state as it passes through each component, taking away heat from the compressed air in the cooler section. The refrigeration circuit used in a refrigerated air dryer is also found in familiar home appliances such as refrigerators and air conditioners. For example, the indoor unit of an air conditioner is equivalent to the cooler section of an air dryer. Next, we will explain two other types of air dryers that use different dehumidification methods from the refrigerated air dryer. The first is the adsorption air dryer, which in this case is a heatless type. An adsorption type air dryer removes water vapor by adsorbing it with a desiccant. It consists of two adsorption tubes containing the desiccant. First, the adsorption tube on one side adsorbs water vapor and produces dry air. Some of this dry air is used to reactivate the desiccant on the other side saturated with water vapor. This process consumes some of the air, as this air is released to the atmosphere. This process is switched at regular intervals using a solenoid valve. By alternating between dehumidification and reactivation of the two tubes in this way, they can generate dry air continuously. Because it uses a solenoid valve, this type of air dryer requires a power supply. The second type is the membrane air dryer. This type uses a bundle of fine straw-shaped membranes called polymer hollow fiber membranes. When air passes through these hollow fibers, their membrane is permeable only to moisture. This property is used to dehumidify the air. Due to the difference in pressure of the water vapor inside and outside the membrane, water vapor is released to the outside. To keep the outside of the membrane dry, some of the dehumidified air is used to flow outside the membrane. Therefore, this type of air dryer consumes air, like the adsorption air dryer. However, unlike the refrigerated air dryers and adsorption air dryers, no power supply is required, and modular connection is possible. This chart shows SMC's product line for air dryers. It also summarizes the features of the 3 dehumidification methods. The dehumidification capacity of an air dryer is indicated by the dew point. The lower this value, the better the dehumidification capacity. Details will be explained later. The most commonly used type is the refrigerated air dryer, which offers a large flow capacity and many different models. This type is widely used for general pneumatic systems with an atmospheric dew point down to -17 degrees Celsius. The heatless adsorption air dryer can produce dry air with an atmospheric dew point of -30 degrees Celsius as standard, and -50 degrees Celsius as an option, which requires a refrigerated air dryer to be installed on the inlet side. The membrane air dryer is available with various atmospheric dew point temperatures. However, note that the flow capacity varies depending on the dew point. Adsorption and membrane air dryers can produce lower atmospheric dew points than refrigerated air dryers, but they consume air to do so. The air consumption is listed in the catalog specifications as recycled air for heatless adsorption air dryers and purge air for membrane air dryers. Note that these types require a supply capacity that exceeds the air consumption and flow capacity. In addition to offering a low dew point, membrane air dryers do not require a power supply, so they can be built into equipment. The atmospheric dew point of the refrigerated air dryer is sufficient for general pneumatic systems, but some industries and manufacturing processes require a higher level of dryness. For example, in semiconductor manufacturing, moisture can cause shape defects and short circuits, so air with a lower dew point is required. Next, we will explain dehumidification capacity and dew point. As we saw in the product line for air dryers, different dehumidification methods provide different dehumidification capacities. The dehumidification capacity of an air dryer is indicated by its dew point. 2 dew point values are used: atmospheric dew point and pressure dew point. We will learn about each of these in turn. To understand dew point, we first need to explain the concept of saturated water vapor amount. The saturated water vapor amount indicates the maximum amount of water vapor that can be contained in the air. The saturated water vapor amount varies depending on the temperature. When the saturated water vapor amount is exceeded, water droplets will form. Let's take a look at this on a graph. This graph shows the relationship between temperature and the amount of water vapor per cubic meter. The curve indicates the saturated water vapor amount at each temperature. As an example, let's find the saturated water vapor amount when the temperature is 25 degrees Celsius. At 25 degrees Celsius, if we draw a line up to the curve, we find the value is 23 grams. This means that if there is more than 23 grams of water vapor per cubic meter of air, water droplets will form. Next, we will explain the process of moisture generation using the saturated water vapor amount graph. As explained in the previous slide, when the saturated water vapor amount is exceeded, water droplets will form. In a factory, the temperature of compressed air may fall due to cooling factors such as outside air temperature or indoor air conditioning. As an example, if air is saturated with water vapor at 40 degrees Celsius, what happens when the temperature falls to 25 degrees Celsius? The saturated water vapor amount at 40 degrees Celsius is 51 grams and the saturated water vapor amount at 25 degrees Celsius is 23 grams. The difference is 28 grams, which means 28 grams of water droplets will form. Thus, from the temperature change, we can determine how much water will form. Next, we will explain dew point. The dew point indicates the temperature at which water vapor begins to form water droplets when humid air is cooled. Here, humid air means air containing water vapor. The dew point is used to indicate the dehumidification capacity of an air dryer. As an example, consider air with 9.4 grams of water vapor per cubic meter at 20 degrees Celsius. When this air is cooled, it reaches saturation at 10 degrees Celsius, so water droplets will start to form at temperatures of 10 degrees Celsius and lower. This means the dew point of this air is 10 degrees Celsius. When selecting an air dryer, it is important to choose one with a dehumidification capacity such that the compressed air temperature will not fall below the dew point. Next, we will look at the different dew point values and how to convert between them. The dew point at a certain pressure is called the pressure dew point. The dew point at atmospheric pressure is called the atmospheric dew point. Pressure dew point is used for compressed air inside an air tank or piping. Atmospheric dew point is used for air at atmospheric pressure, in applications like air blowing and painting. Next, let's see how to convert between these two values. This graph shows the relationship between the pressure dew point and the atmospheric dew point. As an example, let's find the atmospheric dew point if the pressure dew point is 10 degrees Celsius at 0.7 megapascals. From pressure dew point 10 degrees Celsius, draw a line across to the 0.7 megapascals line. Then, draw a line down from that point to find the atmospheric dew point. In this case, it is around -17 degrees Celsius. This shows that the atmospheric dew point is lower than the pressure dew point. This means that as long as the compressed air is at a temperature above the pressure dew point of 10 degrees Celsius, water droplets will not form in the piping. When used for air blowing, water droplets will not form as long as the air temperature does not fall below -17 degrees Celsius. During air blowing, the temperature will drop as the air expands, so the user must keep the atmospheric dew point in mind to avoid contamination by moisture. Finally, this is how to convert dew point values using a conversion table. Using the same conditions as before, if the pressure dew point is 10 degrees Celsius at 0.7 megapascals, we can find from the table that the atmospheric dew point is -17.6 degrees Celsius. Thus, a conversion table can also be used to convert between the pressure dew point and the atmospheric dew point. Here is a summary. Air dryers dry compressed air by removing water vapor. The main type of air dryer is the refrigerated type, which dehumidifies compressed air by cooling it using a refrigeration circuit containing a refrigerant. The dew point is the temperature at which water vapor begins to form water droplets when humid air is cooled. Two dew point values are used: pressure dew point and atmospheric dew point. The dew point indicates the dehumidification capacity of an air dryer. The lower this value, the better the dehumidification capacity. Thank you for completing this module on airline equipment part 3. Now, please check your knowledge with a quiz.